Well, hi, and welcome to my shop, and thanks for joining me here today. A little bit of sun is shining outside, and I'm getting a very late start today. Usually I'm finishing up at this time, but hey, I slept in. Kind of an unusual thing for me. So it's April 20th. Yesterday, part of this radio burned away, or fried away. I'm not sure whether it burned or fried. And while that happened, while I was trying to measure some key voltages in the radio and assess the radio that way, and while I was busy fooling around over here in the part over here, hey, maybe the same thing will happen today. I want to continue with those voltage tests. It seems to me from the little test I did yesterday at the end, when I changed this capacitor, voltages came up. That's not surprising at all. This capacitor was right on the power supply, and this one here, right on the power supply, and the B plus power supply. So it was being fed everything the radio could give it, and you saw the result. So I want to get back to this area here where I had started and continue the process, going through a number of tubes or wherever I can make some kind of meaningful voltage test on the radio. That's the plan, and I'm going to set up for that. Okay, we were in the process of examining two blocking capacitors. That's this one here, which is connected to the plate circuit on this tube with 100 volts on it, and the grid of the next tube. And likewise, this capacitor is doing the same thing, blocking high voltage from the plate circuit previous, blocking it from getting over to the grid of the tube. These two guys are probably these two mica-like or mica look-alike capacitors. They aren't mica capacitors though, I'm pretty sure. And I was measuring the voltage on either side of those capacitors. And the one side we should see, let's look back at the schematic here. One side we're going to see these numbers, 105 and 75. And on the other side, I really think it should be 0. Just 0. How would you get to 0? I get to 0 down this line here. Cathode line. Yeah, so this is a 0 line. Well, there's some resistors here. Shouldn't be any current flowing in the circuit, really? Any DC current? I think 0. I think we should see the full 75 or 105 on one side and 0 on the other. That's my position on this. Okay. Who cares? My position doesn't mean a lot. Okay, we're going to make sure we can turn this guy on now. Okay, once again, I don't know if you can hear it, but there's a what I assume is a filament shake at first in one of the tubes. There's a little bit there. And of course you're listening with a microphone. I'm listening with my ears aimed right at the radio, so I'm probably hearing stuff you're not. Everything seems fine. You can kind of see the dim bulb just through here. Giving it a bit of time. I think we're good. Okay, we're gonna throw the works at it now. 105 supply volts. If by some chance, behind this tuning fork, you can see this meter operating. You can see the pointers almost all the way over. This is a percentage meter, the way I have it set up. And when 100% of the output is heading for the radio, this meter will go all the way over. You see, it's not quite all the way over. It's kind of an odd thing here because 104 volts, 103 volts, yet I'm starting out with 120, I'm sure. Something in my system is gobbling up some voltage. That's bad news. Something, maybe bad connection somewhere, I don't know. Okay, I'm just passing some time letting this guy get good and warmed up. Any sound coming out of it? I've got the antenna switched off, I just realized, because I switch the antenna every evening back to my other office where I am in the evening. I'm not in here. and my shack, my radio shack, or whatever you want to call it. And then I forget to switch it back here. That's what happens every day. Okay, so we're going to read here. I'm going to put this to 500 volt scale. Actually, we can do it with a 150 because we're not expecting anything more than, what was it, 105. Okay, so I don't know if this is the low side or the high side to start with. That's probably the low side. And there's some voltage there. This one's probably the same. There's a little bit of voltage there. Now we'll go on the high side. We should see in one case, so that is 45, almost 50 volts, and the other one is even lower. That's not right. Let's go to 500 volt scale. Let's go on the positive side of this capacitor. So that's just shy of 500 volts there. The actual number is 200. That's actually, did I say 500? That's 200 volts. I think it's supposed to be around 250. Then we have these capacitors here, which I'm beginning to think are really somebody's, like this capacitor here was a replacement by somebody, I'm pretty sure. And these two are also. It's very low. Very, very low. Very low. Now, the reasoning for the lowness I was pondering was the field coil is incorrect in the speaker I've got on this radio. Has the wrong resistance of field coil. And the schematic shows the speaker field coil at 600 ohms. Can I just take an ohm meter and measure this to see? Could also measure the voltage drop across here, how much is on one side and how much is on the other. That's actually a better way because it's right here. I can get the measurement here. So we're watching now. One side, we're just above 200, so make that 210. And the other side, oh my gosh, there it is. So we're losing it in the field coil. Now there's bound to be some amount of drop. 200 is kind of low too, isn't it? 200. So this is the input side of the field coil. This capacitor is on the input side. You go through the field coil, and on the other side are these capacitors, and that's the remaining voltage there. 500 volt scale. 100 volts. You got 100 volts. The other one should be the same. They're hooked together, and 100 volts probably showing here. Same voltage. 100 volts. I've been feeding the radio with 104. Let me crank it up so there's 100 and something more appropriate on the plug here. 113. Let's go just a touch higher. 115. Okay, now what did that do? Did that do anything exciting here? 100 is now just above 100. Below 100 went to just above 100. The maximum is now about 275. But look at the schematic here. I think there are some. So look, 315. That's 315 volts. What's exactly? See, I think he's pointing right at this line here. Why is it? They're pointing at the. Why did they do that? I don't know. Okay. Well, 315. That's got to be the maximum supply voltage. The voltage on the top of this capacitor, anyway. And instead of 315, I'm seeing 250. Down from where it should be. There's nothing in the way of the primary here except this could not pull down you can't pull down the voltage of the entire electric system in Ontario with these two capacitors. So this is bound to be getting the right input, and the output, assume the transformer is good, is going to be, I could measure this. I could pull this tube out and I could measure the open circuit voltage, but there's nothing written here to let me know what it should be. Especially with no load. Uh-oh. What's that? Something's giving up the ghost here. I'm trying to identify that. Can you hear that ticking? Bad news, man. What is it? It's fading out. Oh, something is definitely failing here. Okay, I'm watching the... what are you watching? Huh. Boy, oh boy. Waiting for more smoke to evolve. There isn't any. What do you do about this? Just flexing parts to see if anything changes. The sound is over here. I would say it's a coil or something behind here. No reason to think touching isn't going to make anything happen either, but what else you got to do here? It seems to change it here. Is that sound coming from the speaker? Is that what I'm hearing? Oh my gosh! Okay, it's nothing. That's the thing about those speakers. Darn things make noise. Okay. Maybe I should have thought of that first. Okay. Well, I managed to poke all these parts and nothing happened. Maybe that's a good sign. Let's see what's happening with this voltage, by the way. Sounds like a microphonic tube here. So that's on the 15 volt scale. So you have 15 volts in both cases. And the input side, as we looked before, was low. At, what did I do there? 150 volts on the radio, on the meter, 150, 40 volts. That should be 75 or 100 there. There's 40. And even less over here, so it's probably 100 on here and 75 on there, and they're both quite low. In fact, probably everything is going to be low because this guy is low still. It won't have gone up. It's supposed to be 315, you know, and it's 275. That's not that far off, really. we got 115 volts on the plug. If I put that up to 119, this would probably go up to where it should be. Why don't we try it? So what if the outlet voltage were a little higher? What if it were 119? Now you get 300 volts there. But these won't have come up. They're still down there. $150 volt scale. Yeah, they're still down there. And the voltage on the other also is going to be. So this has to be heating up. That's 100 volts. So we're losing quite a bit of voltage right across that field coil. That's way too much. So meaning the long-term operation of this radio would probably heat that speaker way up. Long-term being an hour or something like that. So some kind of heat run test got to be done to conclude, you know, how long you can operate a radio like this with that speaker. What else can I do? Can I bypass the coil with a resistor? I don't think so. I don't think there's anything there. But I don't think there's much I can do here about this. The radio's going to operate with a lower voltage. What about the output tubes? Would they also be getting this low voltage? The output tubes are these two guys up here. Let's look at the schematic before I poke around. So we're getting about 300 volts here. 300 volts, right? But then it goes through the field coil, Jim. Everything's on the far side of the field coil. So the plate voltage on the output tubes is supposed to be 230. Look at 245 over here. We're nowhere near, I don't think. So the plate is the same on all four of those tubes. 1, 2, 3. Third pin is the plate. So we can do a bunch of plate voltages pretty easy here. So at 500 volt scale, these tubes should be coming straight up, more or less, on pin 3 of every one of these. So here we go. Here's one. That's not straight up. Okay, pin 3 would be this one. That's not straight up. And pin 3 would be this one. They're all going to show the same. And pin 3 over here. I mean, the voltage just can't make itself appear halfway through the radio. Ultimately, that would cause a lower output volume because of the lower B plus here. But there's lots of volume. There's tons of volume. Hey, it's a problem that isn't really a problem, other than the heating of the field coil. And the heating of the field coil. Let me check it. If you stood up straight for a while, you'd feel better. Here, that's better. Instead of being bent over the way you were. Here we go. Well, it's warm. I mean, it's you know, it's not room temperature. It's definitely heat evolving in it. Watch what you touch now, Jim. But all these things get a little. They get nice and kind of comfortably warm. Speaker field coils. Well, I could let this operate for a while. The problem with that is I don't dare leave the room because we had a fire. if I go watch TV, I may come in. There'll be flames flying here. So I kind of have to stand here. So let's keep fooling around while we're waiting for it to cook up. What else would I measure? Well, even though the voltages are low, they should still be there. So, and the radio's operating. So, I mean, how bad can any of this really be? Really can't be very bad. What can I poke on? Like I'm reticent to do this because I don't think there's anything coming out of it. Looking for voltages. I don't know, should I get my guitar and play some songs here? What should I do? Leave briefly and keep coming back over and over? We really do have to let this thing run for a while to really get a notion as to how hot that field coil would get. Okay, well, I'm not going to keep the video running, that's for sure. That terribly annoying interference just died off, and instantly I could hear the station. You could barely hear that station before, so wish I knew what the noise source was that haunts me every morning in this house, but okay. I was fiddling around with the antenna connections. They don't seem rational to me. What's going on here? Oh boy, careful. If I connect the ground lead from my antenna system, which is a coax cable system, it introduces a lot of noise to the radio. But if I just hook up the center lead, it seems to operate right. I've hooked up the center lead, not to here, but to the loop antenna lead wires, just one of them. It seems to me you just never know. You never know how an antenna and ground is going to work on a radio until you try this, that, the other thing and find out. Okay, so my idea is to spend time. I'm spending time here. Okay, so it's a little warmer yet. Still just warm. Let's see what else we can pick up here. Not particularly strong reception. Okay, like my antenna is producing strong signals all through here. Radio just wants to pick up a bunch of noise. Except way down here. Hey, look, I'm tuning it back and forth. Huh. It could just be the interference is so high, we can't hear all these stations that are under it. Okay, let's go for some shortwave stuff here. Go first shortwave band. Wow, barely hear that. Okay, we'll take the antenna off the back here. So now I have a schematic that showed these two soldered together, and there is a wire between them, soldering them together. I have another schematic now, the one I'm looking at, the one you're looking at right here. I can show it to you for crying out loud. For crying out loud! That was my parents' phrase. So here's the in connect. There's no wire between them, and ground terminal showing below. Yeah, I guess you could say that. That's a ground terminal screw there, I guess. So why you got two connections here, one marked A and the other marked O? That because you're supposed to put your it goes right to a transformer. One side grounded. I think if you're going to use a wire antenna, you might want to put a ground in here and hook up your wire antenna there. That would make some sense. What's this doing here? Don't know. This must be the loop antenna that's missing. The loop antenna is grounded. It's always active. Always active. Is it? Does that make sense? No, it doesn't. Like, would this loop antenna be pushing stuff through this coil down here? Only if it connected to both sides. Okay, not exactly sure what's going on there, but I got some notions anyway. If I hook up like these terminals here are soldered together. If I cut the wire, one terminal's hooked up to nothing after that, nothing at all. What's that all about? Let's look at another schematic. Maybe not that. This is the one we're looking at. Here's the other one. See here, oh, you know what, they're probably showing, well, what are they doing here? The antenna up there, can you see this? You can't even see this. Hang on a sec. Hang on a second here. Okay, so we're looking over here. So here's the antenna. It says yellow. It's not the, this is not the antenna, because it gives a yellow wire color. How would they know what color your antenna wire is? So this could be that plate that's on the side of the radio, and this could be the loop antenna that's missing. Well, here they show terminals. AD, AD. Oh my gosh. They don't have. They do have another set of terminals on the back, but those are input terminals for, that's these here. They're the input terminals for the phono. So my radio does not look like this. But down here, they, wait a minute. They have a loop antenna here. What is this? This is an inductor of some sort. So like, is this all, this is all added in? And then they move this symbol down lower. They move, so the symbol's up higher, and all the stuff disappeared. Oh, wiring diagram for your radio. Well, there's no doubt then, this is what I've got, because it's my radio here. So what do you make of this? What do I make of this? Well, maybe a loop antenna is supposed to tie between here and the chassis. This is some kind of, I don't know, low frequency bypass to ground thing or something like that. It's how they can put a ground on here but still have some reactance towards high enough frequencies or something. I don't know. I don't know what they're doing. What are you doing here? It's so simple. That's the problem. I'm too simple. Okay, let's go back. Right. Wow. Okay, heat check. Remember, I am running a heat test here and standing by. Okay, it's getting warmer. Now it's getting to the temperature where you might go, ooh, is that going to be a problem? We'll have to read the actual temperature at this point too, because I need to know if it's continuing to rise. So we'll take a temperature reading now. So this device is pretty cool. In the center is a white plus sign. You can see it there. Whatever that white plus sign is sitting on top of, the temperature of it is written there in the big letters. So that plus sign, it's 20, well, it's jumping all around, but it's around 30 degrees. So, you know, everything in here is around 30 degrees. This is the whole area of the all those tubes and their tube bases. It's getting pretty warm over here too, 30. So I can make the screen less sensitive so it doesn't turn completely red all the time. And whoops. That's better. Made a little mistake there. Okay. Now, only things that are above 35 degrees are going to show up as red. That's a tube socket there. Just making a quick check through here. Something quite hot up in here. It's very hard to tell what this is looking at. What could it be seeing down through here? No, it's just looking into the. It must be seeing. Oh, you know what I think I'm seeing? I think I'm seeing the edge of the magic eye. I think that's what I'm seeing. The glass of the magic eye. Okay. What about the speaker? So what I can do, tip this forward, put this like this. 36, 38 degrees. 40 degrees, that's getting up there. That's definitely getting up there. 40. So it's at 40, so we'll let it run while we fool around here, and then we'll check it again in a bit. and see what's happened to the 40. Okay. Yeah, no antenna. Okay, so we're fooling around with the antenna. I'm going to put it on the antenna lead here. Should have had the volume up a bit. The ground, if we put the ground on, more juice through it, but all noise. So we think we're on the first shortwave band. What frequencies are we looking at? I don't know. Pointer's way off. Okay, next band. Less noise. Come on, keep tuning. You can do it. Doesn't want to continue. There we go. That's weird stuff. What was that? Quiet at the top. The last band was quiet at the top. Nothing heard. That's radio talk. Nothing. Not very reassuring. Nothing, nobody know how. Got more life in it. It's very bad. I'm going to put the ground on and go back. Wow. Hey, you just never know. Finally. What was that? What was that? Is that something to do with this? Radio? Here are the birdies. Bad capacitors. That's what I would say about that. Okay, next band. There is no next band. That's the end of it. Did I do all those bands already? 1, 2, 3, 4, 5. I guess I did. Okay, where are we at now for the temperature? Only let a few minutes go by. 42, so you see it's still rising up in temperature. I would say if it got up around 55, I would be panicking. I would say, oh wow, we have to do something about this. Even at 40, 40 is not very comfortable. For me, anyway. Yeah, 40 is where you're going, should this get this hot? That's kind of where that's happening. Well, it's not much here happening today. Heard the birdies during the tuning. Certainly indicates capacitors are not doing well, certain capacitors. The low voltage, I pretty much convinced myself it's falling through the field coil and we can't do anything about that offhand. I don't have another speaker. I mean, I'm lucky I got this one, really. How often do you have a spare speaker like that? How often do you have a spare speaker like that? Well, never. Who's got spare speakers like that? Well, yeah, I'm rambling, so I think I'm going to call it quits here because it's late in the day already. Thanks a lot for watching. Not sure what I'm doing. I'll do something more tomorrow. See ya.